This is Professor Derf Seitz. This Java tutorial is about conditions. A condition is an expression that returns a true or a false. Conditions are used in selection statements such as if statements, while statements, switch statements, for statements. In this tutorial we're only going to be looking at the conditions in isolation, which is not how they're normally used, but to study them, that's how we can cover all of them in a brief amount of time. Here we have our main method inside the conditions class, and we will run several functions to test each one of the kinds of conditions we want to look at. Down here are the functions. The output will annotate itself. First we'll be looking at equality, equal of primitives. We'll have an I and a j set to a 1 and a 1. On the next run we'll change the value of j. There's test values here, but we'll start with a 1 and a 1, and we'll do a comparison, an equal comparison. Similarly with booleans, with a false and a true, we'll do a comparison. The next function, we'll look at floating point equality. Floating point equality, we'll start out with two doubles that are equal, but then we see some anomalies here. If you add 1/10 7 times, or if you take 1/10 and multiply it by 7, you would think you'd get the same answer, but we're going to find out that there's a slight difference because of the inherent possible errors with the precision of the floating point numbers. So the technique to determine whether things are equal is you take the difference of the numbers, look at the absolute value because it might be negative, you make it positive, and if it's less than what you consider a practical zero, which in our case is going to be 1/10,000ths, we'll consider them to be equal. Here's a case where we could have a float and a double, 1 divided by 3, float and double, and we'll get the same kind of a situation where they will not compare equal with the equal operator, and we'll have to use this difference, small difference technique. When we're comparing objects, object equality, we have to use the equals function, not the equal operator. So to compare two strings, which are objects, we'll use the equals function. Not equality is the not equal operator, and we'll compare integers and booleans with the not equal operator. The relational operators, there's less than or equal to, greater than or equal to, and we test here each one of those with different sets of integer values. The logical operators, first logical and takes two operands, and it's true only when both operands are true. If either one of them is false, it'll return false. So we'll look at some booleans and AND them together to get the different possible values of two operands with trues and falses. For the logical OR, the double bar, it will be true if either one of the operands or both of them are true. We'll look at all cases of that. And then the logical NOT is simply the exclamation point, and it negates whatever the value of the condition that it modifies as a unary operator. We're going to run this code now. Here's our output. We compare 1 to 1 with the equal of primitives. It's true. Compare two booleans that are not equal. Compare equality is false. For floating point, the two doubles that are the same, compare true. This anomaly with the arithmetic here, notice that we get a 0.7 for the addition and a 0.7 with a 1 way out to the right for the multiplication. So when we compare them, it's false. If we take the small difference approach, we get a true. Comparing the float to the double, again because of the precision, they're not equal with the equal, but with the small difference they are. Comparing two strings, we have to use the equals function. Here they are the same. We compare them with equal, and we get a false because that's not how you compare objects. Comparing it with equals, we get the true correct result. Not equal, 1 and 1 is not equal, is false, they are equal. And a false and a true, is it true that they're not equal? Yes, it's true. The relational operators, less than or equal to, greater than, and greater than or equal to, compare the numbers for us and give us what we would expect as a result. Here's the logical AND for the first run of it with the values we have. A false and a true is going to be false because of the false. A true and a true, they're both true, we get a true. Logical OR, false and a true, one of them's true, so we get a true. A true and a true, both of them are true, so we get a true. The logical NOT is going to negate, so if we compare I equals J here, which would be true, negate it, we get false. Compare Booleans, a false and a true, they're not equal, negate it, and we get true. Let's go back into the code now, and we're going to change the test values. All the values that were to be altered have been altered. For example, we are using 2 here instead of the 1 that we did with the last test. Here we're using false instead of the true. All the way down we've changed so we get a new set of values that the conditions will be exercised with, and we'll look at the output for this test. Here we're comparing 1 and 2 for equality, false. Comparing a false and a false, Booleans, true. The floating point, we changed one of these floating points to have a minor difference, and it does detect that they're not equal. We get a false for that condition. This condition here, there was no change to that one and no change to this test. Object equality, we changed one of the strings to say sycamore and the other weeping willow. Both times we get false here, so the equals works for all cases, whereas the equal comparison does not always work. Not equal to, we've changed some values here, 1 and 2. Not equal is true. False and false, it's not true that it's not equal. The relationals, we changed the value to 1 and 1. Is it less than? No. Is it less than or equal to? True, because 1 is less than or equal to. It gets a hit on the or equal to part. Logical AND, false and false is going to be false. True and false is going to be false. Logical OR, false and false is false. True, well, false or false, we're doing an OR. False or false is a false. True ORed with a false is a true because it only takes one of the operands to be true for it to be true. The logical NOT, here we've changed our second operand to be a 2. Is 1 equal to 2? It's not, but the negation of that is true. A false and a false, are they equal? They are, but the negation of that is false. Let's go back to the code. We're back in the code, and we've restored all the values to their original test conditions. Reviewing the different conditions available, equality testing of primitives, floating point equality. You have to be careful there and sometimes have to use the practical zero approach. Object equality using the equals function. The not equal to conditional. Relational operators. Logical AND. Logical OR. And logical NOT. In all these conditions, we've shown inside a pair of parentheses because that's how they're normally used in selection statements. So this should give you a good overview of what's available with conditions, and it'll make it the next tutorial on selection statements, we will be using conditions in if statements, in switch statements, and in looping we'll be using conditions. So now that we know about conditions, it'll be familiar when we look at these other kinds of statements.